Today is a red letter day, a very auspicious day, and that is we are finally putting this VFD on the lathe. I say we because I got a friend here helping me doing all the bitch work for me while I do the fun stuff. Say hi, friend.
What's up?
So anyway, this is a Invertech OptiDrive. It's the E3 actually. I thought it was E2. Whatever. This, I don't know if this is their newest model. It was relatively cheap, so that's why I don't think it's their newest model, but it's 5 horsepower capable. The motor on this is 5 horsepower. And I think that adding the coolant motor to that, which is like 1/70th horsepower, isn't going to make much of a difference. So I'm not that concerned about it. We're just going to send it and see if it works. So the idea right now is the I'm being lazy and don't want to do a lot of wiring idea, which is that we're going to wire the 2-phase directly in and then just take 3-phase directly into the box, like just into the normal input. So that's going to make this kind of like the mill, but I think that the mill, I don't like the startup sequence. It kind of pisses me off having to do the weird stuff with it, starting it up every time. This one is going to be, I think, a little bit easier because it's not a button, it's actually a switch. And so we're going to have this switch in the on position, which is all unplugged and everything right now. Have this switch in the on position and then start the VFD. And that will start the main motor. And then after everything's started up, we should be able to start the coolant motor and not have any problems. At least that's the idea right now. So we're gonna wire it up and test it and see if that works. And if that does work, then we're gonna try and find a mounting position for this, I think, because I don't wanna just leave it laying on the floor. All right, after a quick trip to the store to get wire that actually fit the VFD, we're back, and what are you doing right now back here?
Well, wiring it up, wiring this up to the VFD directly. Got a little more wire, so we should be able to hopefully bring it around front. And next step is plugging this in and getting it all to work.
Okay, about where you at on that? You get the so the VFD is wired to the box, right?
Mm-hmm. Yes.
Okay, and then have you got the wiring done for the like extension cord going back to the mess of wiring over there?
No, not yet. We're not there yet. But we will be hooking it up to the 240.
Okay, and so let's see, we got the VFD down here.
Yeah.
And so, yeah, this will be fine for testing, and then I think we should be able to get that to reach. I think we're going to mount it onto this back panel here. I think we've got enough cable for that. I was thinking about possibly mounting it up front. Maybe this panel that's been missing here because I never put it back on. I'll have to look and see. Actually, no, it's over on the welding table. I'll have to see if that might be something we could just drill through and mount it there and then put it on the front. I don't know. We're gonna keep chugging away at this, and I guess I'll bring you back once we actually get it all wired and get her started up. And we are alive, sort of. I don't really remember how to use this thing. It's been a little while since I used the last one or set it up. I might have to go grab the booklet if I still have it and try and figure it out. Don't mind the bare wire hanging in the breeze. That's supposed to be like that. I know that there's like a bunch of different settings in here, and I don't remember. I'm gonna have to get the manual, because I think it's like, I think 12 does something. You see here. Yeah, I don't know. Well, I'm gonna get the manual and try and get this set up so I can actually use it, because right now the green button does not make it go, and this is upsetting. So let me do that, and then we'll see if she runs, and then hopefully get it out of this temporary position. All right, I'll be right back. All right, so I did actually do some testing off camera because we were having a couple of issues with the VFD and getting it started. I hadn't really thought about this, but as soon as it happened, I knew exactly what the problem was and remembered having this with the mill. Contactors do not like to be run at lower than their rated frequency. And so as the VFD spins up, the contactor is very angry and is not actually closing the connection. And so what happens is it starts to spin up, or well, it starts to try to spin it up. The motor's not actually spinning because the contactor isn't contacting yet. And once the contactor actually gets into full contact around 30 hertz, the thing just cuts off for an instantaneous overcurrent, because all of a sudden the motor is there and it can start spinning it, but all this time it hasn't been there. We have found a way around this for the moment. Ultimately, I think what we're going to do is remove the contactor and just bypass it, and it means that if we wanted to run the lathe backwards, we're going to have to use the VFD to do that, which means we can't use coolant if we're running the lathe backwards, which sucks, but I have a plan in store for that. I think I'm going to try and replace the coolant motor with a different motor, like a single phase, and just some other control logic that's independent, so we don't have to worry about that. But for the moment, we do have a way past, which is my buddy here will be over here at the e-stop button that we've wired up to start the thing, which is in a very safe and secure location on the little stool of power here. And then I am back in the electrical box with a flathead screwdriver, forcing the contactor to contact until about 30 hertz when I run away like a little bitch. We have this thing set to full speed right now, which is 1120 RPMs if you remember. But I decided that that wasn't really quite enough. So today marks the first day that I have overclocked my lathe. And it gets kind of scary, especially since this thing really needs to be leveled properly, because I think I just made it worse the last time I tried to level this thing. But I'm not just going to let you guys not get to see that. So we're going to turn it back on to the fastest that we wanted to run it, and not feel like we were going to instantaneously die, which is 90 hertz. We should bring that 1120 RPMs up to 1700, 1800, somewhere in that range. And you'll get to see firsthand. So without further ado, let's do it. Ready? Go. So when it hits 30,
15 hertz. 25. 30.
Jesus Christ. We're 79, 80. Up to 90. All right, let's take a cut. Oh, Jesus. Oh, boy. Okay, that was just as scary as the last time. Oh, never doing that again. Probably gonna do this all the time. But, I think we're getting to the speeds that carbide actually likes. This is a respectable surface finish, And I've gotten pretty good surface finishes out of this before, but this is without coolant, and at a pretty good clip here. Of course, if we had a wider piece, we could possibly get even better, because get even higher surface speed. But this is being this small, you have to spin really fast to hit those surface speeds. I think we're probably in the ballpark. I think at this low of a diameter, we probably need to be closer to 2,000 or 2,500, but I didn't run it through the calculator yet, so I don't know. But, I mean, it's respectable. So this might be a trick that I keep up my sleeve for days that I'm feeling really ballsy, and possibly have someone here to call the ambulance when the lathe sucks me up and kills me. But, yeah, I'm pretty happy. So, now we get to the fun part, which is bypassing the contactors. So we're going to do that. And I'll see you guys in a little bit. All right, I figured I'd give you a short tour around the box back here because I kept meaning to make some kind of video about this, but I don't want to get too in depth because I'm just trying to fix this up right now. We have the two contactors here, and this one is the forward one, this one is the reverse one. Everything's unplugged, so there's no power in here or anything. And the way that they normally do these, which is how this one's done, is they just take power from the forward one and put it into the reverse one, but they swap one of the phases so that it'll reverse it out. And then the power comes out of reverse and the forward into a motor overload, and then from the motor overload down into the motor somewhere down here. And then there's a lot of control here, like these transformers are for getting to lower voltage for controlling these. Some of these wires are they go back to like the switch on the front. Once that closes the connection, it allows the contactor to push in like that. And then of course you got fuses, all this stuff. But so what we're doing right now, just to get this to where we can use it, is this is one of the phases out of the forward power, which is right here, and this is one of the outputs. And I'm taking this, I'm trying to just get a wire nut on it, and they're all, as these machines normally are, they're all solid core, and so I'm not certain that this is going to work too well. I might have to get like a pair of pliers and wrap them up or something, but I'm going to try it. If we end up with a bunch of like melted burning plastic smell, then maybe we'll try the other way. Anyway, back to it. All right, so the caps weren't working. This is what not to do 101. Stay in school, kids, you'll end up like me. All right, so I went inside and had something to eat, so it's kind of dark outside now, but do have everything wired up in the back. It's a little bit sketchy. Probably need to at least put some electrical tape around those connections or something. I might solder them together maybe, but it is ready now, and so we shouldn't have to do any crazy shit there in the back. I should be able to just pull out this e-stop button and it'll start. And this is our good old, for testing purposes only, e-stop button, and I doubt that this will end up being the final thing here. I think what we're going to try and do is wire this in, and that's going to require basically tracing these cables, figuring out where they go, and then I think pulling them out of the box and connecting them to the VFD, which will be hopefully mounted on the back there. But anyway, here goes nothing. Looks like we're just now at 60 hertz. I don't know if you can read that, but we're now at full speed. It looks like we're working. It's working. All right. Just face a little off. Like so. And then I don't want to ruin this nice surface we made with the super fast speed. I'm gonna just go back here and maybe do a little bit of power feed. Nice. Not bad. Let's stop it. Much cleaner stop. I think there's some brake stuff I can put in there, and deceleration time and all that, and like DC injection, all that kind of crazy shit. Maybe get it to stop a little bit faster, just in case it is like an oh shit moment and I need to stop it right then. And considering that originally this lathe did have a brake, but since we have a different motor on it now because the old one kicked the bucket, it no longer does. So next thing up is we gotta get that mounted, and then hopefully maybe try and wire this in. It shouldn't be too hard. It's just that switch, and then I think we'll be basically good to go. And I think we're good to keep the current coolant pump in there at the moment. I can't think of the last time I needed to run the lathe backwards and use coolant. I'm certain now that I said it, I'm going to need that feature tomorrow, but at least at the moment I haven't used it ever. So we're gonna just leave it how it is, and then maybe at some point we'll get a different coolant pump back there so we can have a whole different control system and not have to worry about having the coolant pump run backwards because we're running the lathe backwards. But yeah, she's working out. So almost ready to start the next latest and greatest project, which you will hear about soon. Anyway, let's get this mounted and I'll see you later. All right, getting back here was a bit of a chore. I was starting to mark out the VFD back here so we could get it, get the holes cut, and we also got the cable. So that's that cabling that comes from the front. So it's all ready to be hooked in when we decide which two need to be hooked together. But I couldn't quite get the marker through the holes, so I've just kind of outlined the top of it here. I'm gonna guess about where the holes are at, which I think is a very, very smart plan. Or if it's not a smart plan, it's the plan we're going with. So we're going to drill these two, and then I'm going to try and mount it. And then the bottom two I might be able to drill, because they're just like little pegs, I might be able to drill with it on there. If not, then I will just mark those, because I know I can mark those. But I want to get the top two drilled first and then put it on there. I've got this pretty close to the box, and reason being is that cable only has so much length, and I could probably fish a little bit more out if we fucked with some other stuff, but I just didn't want to mess with it. So it's gonna be pretty okay. I think this is a fairly decent spot. The only issue I have is it's kind of like right in line with the chuck, so if chips fly over this way, they'll probably fly directly on top of this and ruin it. So got an idea for that I'm gonna try out, just not right now. Anyway, let's get to drilling. All right, so we've got it hooked up back there. Kind of got lazy, only put 2 bolts in, but it's held on pretty firmly. You can see it's right here. The wiring's kind of exposed, and there's some other weird shit here. My plan is to put a little bit of enclosure around this. I can see that some droplets of coolant made it on this in the initial testing, and so we'll definitely be putting some kind of enclosure around this just to keep it dry and nice and all that. So we'll figure that out, but it's there and it's hooked up, it's powered, and as you can see by the coolant that already made its way on there, well, it works. And that is controlling from right here. So we did actually get it wired up, so we're not having to use the emergency stop button anymore. So if we flip this down, now unfortunately we don't have reverse hooked in yet, but we're gonna be looking into that soon, and once we get that hooked in, we'll be able to reverse it as well. But I've not had to use reverse on this like basically at all, so I'm not that worried about it. So yeah, I think that it's in pretty good shape. Definitely good enough for the next project I have planned for it. Which right now I think that is, I finally will make that arbor for that shell mill that's been laying around. This one that, you know, trying to remember when I showed this to you guys. You might not have seen it yet. This might be in one of my go-kart videos. I don't know. But it's a nice big-ass shell mill. It's awesome, and I really want to make an arbor for it so that I can put that on the Van Norman, and then since it's a really wide cutting area, since the Van Norman can't spin that fast, it might make up for being able to not spin that fast and get a faster surface speed, get better surface finishes, and of course take really wide facing cuts. So and that's going to be important for a project I have planned that's going to involve a lot of the Van Norman. Unfortunately, there's a couple things that have happened with the Van Norman. Nothing serious, just I've got to work on the backlash adjustment nut again, and I want to work out some of the problems I was having while making the go-kart with it. So I want to get all that worked out, and then we'll be working on the next project. And well, I can't tell you exactly what it is right now, but it does involve my excessive consumption of soda. So anyway, I'll see you guys later.